Hi everybody, we're going to do 17.1. So we're in the last chapter of this semester. We're going to do 17.1, 2, and 3. And today we start with solving quadratic equations. Quadratic means that you have an exponent of 2. So you have something to the second exponent. So let's go ahead and I'm going to put one of these up here. It's the first example on the notes that I gave you. So it's an equation because it has an equal sign and something on both sides of it. It's a quadratic equation because you have x squared. Now, if you think back to chapter 16, and actually, let's see, we skipped 15, and 14 and 13, we talked about factoring, and we said whenever we have something squared, that we typically factor it, and that's going to be true in this section. We may have to take a little square root of something, but typically we're going to factor. Now, in the last section that we did, when we did 16.6, they all had radicals. Remember, we had all these radical problems. And remember, that's when we had to check for the extraneous solution. So when you're given equations that have radicals, those are the ones that you check for extraneous solutions on. That's not going to be what we have to worry about on the quadratic equations. The quadratic equation, since it is to the second power, that means that there's going to be two answers. There's going to be two solutions. So we're going to go ahead and we're going to factor this. So remember when we learned to factor, and I told you I know that you hate it, but you're going to use it. This is where you're using it. So this is going to factor into two binomials. In our A position, we're going to have x. Now, when we look at this on our equation, both of these, the first and the second operation, are both subtraction. So we know that in our binomials, we're going to have a minus and a plus. So now we're looking for factors of 15 that when we find their sum, it's going to give us -2. So what factors of 15 do we have? We have 15 times 1. There's no way we're going to get 2 out of that. We have 5 times 3. 5 times 3. If we find the difference of 5 and 3, it's 2. So we said that one of these is going to be a plus and one of these is going to be a minus. So which one is going to be negative? The larger one, the 5, because we need the middle term to be a -2. Which means that this one would have to be 3. And we can check it like always. So we got x times x. We've got -5x. We got +3x. And we got -15. That's going to give us... Yep. So that's exactly what we want. So that was an easy factor for us. Now we use our idea of 0. So we're going to set this equal to 0. We have to solve for our x. So this x is going to be 5, and this x is going to be -3, because I just solved for my x's. And we talked about in chapter 16 that we put our answers in a solution set. And you can go back and you can plug -3 in and check it. Then you can go back and put 5 in and check it. And you will find that both -3 and 5 are the solutions. So, a couple things. Quadratic equations. Equations. We have our equal sign. We have something on both sides of our equal sign. Quadratic, because we have our variable that's squared, raised to the second power. We learned several chapters ago that when we have something squared, that we typically factor. We factor it to find our solutions, and that's what we did. So, you've been doing various parts of this for quite some time. It's just a different way of pulling it together now. And you don't have to check for extraneous solutions because these equations do not have radicals in them. Okay, let's look at our next one. So that's when everything, that first equation that we had, everything was on one side of the equal sign with a 0 on the other. Now our next example, we don't have that. We have x squared on one side, but then we have 400 on the other. So we want to get this set up so we have our x squared and our 400 on one side and just 0 on the other. So how am I going to move my 400? It's positive right now. So I'm going to subtract 400 from both sides. That's going to give me x squared minus 400 equals 0, because that cancels out, right? Now what are we going to do? Well, this is squared, so we're going to factor. So our a has to be just x. Now, when we look at this, we can see it's subtraction. So what we're talking about are perfect squares. And our perfect squares, when this is subtraction, is we're going to have, for one of our signs, we're going to have minus, and one of them are going to be plus. So if we think about this idea of perfect squares, if we take x squared, the square root of it, we get x. If we take 400, the square root, we're going to get what? 20. That's a shortcut. You can go ahead and you can factor this out long ways if you want. You're looking for something, your A position is going to be x, and then you're looking for something, these are both perfect squares. So you can try to take a long way out and do a lot of doodling off to the side, or you can go ahead and just apply the fact that these are both perfect squares, which is one of the techniques that you learned several chapters ago. So now you're going to go ahead and you're going to set these equal to 0. And this is what I've been trying to tell you all semester, that if you didn't learn the stuff when I was telling you to in each chapter, because I'm very honest with you, you're going to need this later, guys. You're going to need this later. And if you didn't learn it, now it's coming back to bite you in the butt. Okay, so this makes sense. We have two solutions because this is squared. The exponent tells us how many solutions we should have. We're going to go ahead and we're going to write this in a solution set. And on the notes I gave you, I think I actually, let me look. Yeah, I actually wrote off to the side. You can look right there and see I wrote perfect squares. So if you need to go back and look at your factoring notes, that's what you're looking for. You need to review the fact that they're perfect squares. So let me get this off here so I don't confuse anybody. Okay. So again, that's compared to some of the factoring that you guys have done, that's easy factoring for you. It is. Okay, so this is a problem that you're given. This is the work that you show me on the test. This is your final answer. Let's look at another one. And if you didn't know if 400 was a perfect square, you could put it in your calculator to find out real quick. 400 square root, it's going to come out and say 20. So let's look at another one that I think is a little bit easier for you to recognize. If you're given that, and it says solve the equation. So your instructions would say solve. You should right now straight away recognize 49 is a perfect square. To solve it, I have to move 49 to the other side. I do that by subtracting 49 from both sides. That cancels, leave me with 0, equals, I got 49x squared. So they're both perfect squares, so I go ahead and I factor like I did last time, my previous problem that we just got done with. I know x has to be in my A position. I know that I'm going to have a plus and a minus. The square root of 49, 7 times 7 is 49. I have to use my 0 property so I can solve this. And since this is a quadratic, I know that both of these that I solve for are going to be in my solution set. I don't have to worry about going back and finding out if one of them are extraneous or one of them is extraneous. So far we haven't done anything new. You guys know how to solve a quadratic equation, even though you may not have known that you knew how to do it. You solve it by factoring. You set your binomials equal to 0, and you solve for your x. You guys already know how to do this. Okay, let's look at another. So I'm on the back side. It says the square root property says that the solution will be both positive and negative right up here at the top. And you can write this when it's the same number as plus minus. So down here on this one right here, instead of writing negative 7, comma 7, you could have just written in here plus minus 7. That would have been okay as well. Okay, so our instructions are still solve. Yes, I'm down to blue, which means my blacks are running out. Okay, so solve. How do we solve it? We have to have everything on one side, so we're going to move the 11 over here. So we have to subtract 11 from both sides. That's going to leave me with 0 equals x squared minus 11. It's squared, so I'm going to go ahead and factor, if possible. So the factoring that we did before, we said both of these were perfect squares. So 11. 11's a square is a perfect square for what? Nothing. 11 is not a perfect square. So what can we do with it then? If they're not perfect squares, how are we going to factor it? Well, if you would have gone ahead and done this by this point in time when you got here and you looked at it and you said, well, wait a minute, x squared, this would give me x right here. And if I'm still thinking perfect squares and I've gone this far, now I'm looking at this, and if I'm like, I can't remember, I put this in my calculator. The square root of 11 is some decimal. That tells you this is not going to work. I can't solve it this way. There's a reason I wrote it out like this for you. So when you get this far and you're like, I can't write it out this way, you need to go back to the drawing board. So you're not going to do that. I'm going to leave it on there so you can see that you don't do that. You have one other thing in your bag of tricks. What can you do when something's squared? This cannot be a final answer because I could have x equals 11 but not x squared. How can I get rid of that square? We talked about it in chapter 16. We take the square root of both sides. That's going to give me x equals... Now, the square root of 11 is going to be some, long decimal. So it's okay for you just to go like that. And in my solution set, that's just what I'm going to write. I don't want you to go ahead and write out the long decimal. I don't want that. I just want you to leave it as plus minus square root 11. So in the beginning, I tricked you. I tried to lead you going down the same road of what we just did on the first couple examples. But hopefully by here, once you got these placed and you came back to this and you were like, okay, that's a perfect square or what? You were like, oh crap, it's not a perfect square. So I have to be able to do something different. All right? That's when you have to go back and think about what you just learned in chapter 16. When you have a variable that's squared, the way you can get rid of that squared is by taking the square root. And what you do to one side, you have to do to the other. So once we get that just x, not x squared, we can leave this as just 11 under the radical because 11 is not a perfect square. But you have to remember, like you just learned a second ago at the top of this page, that there's always going to be a positive and negative, a plus and a minus solution. All right, let's look at another one that'll be a little bit tricky. This was kind of tricky. That's why I wanted to be sure that we went over this. Let's look at another one that's going to be a little tricky. So, let's see. Okay, so you look at that, and right away, you're thinking to yourself, 9's a perfect square. 9's a perfect square of 3. Okay, so if we move it to the other side, that's going to give us x squared plus 9 equals 0. So when we do our perfect squares, is it with a plus or a minus? Isn't it the difference of squares? It's the difference of squares. So this isn't going to work. So that we can't go that way. That's not going to work because we work with the difference of squares. And yeah, it's negative over here, but when we move it to the other side, it becomes positive. It's no longer negative, and we only know how to do the difference of squares, so that's not going to work. So let's look at this. What can we do with this? Well, this has got a square on it, so we know that we can take the square root of both sides. So the square root of x squared is x equals, so now you got this. Now, oops. Now this is something, but your book, and for this for this math class, we don't go into what it is. So you can just write not a real number. Your solution set, you can just go like that. But in real life, when you look at this, I told you you can't take the square root of a negative number. Well, when you're talking about the square root of a negative number, you're talking about imaginary numbers, which you go into this in your next math class. For this math class, this is your final answer for the test. In your next math class, very early after the class starts, they're going to tell you, okay, we can find the square root, but first we have to take the negative out. When we take a negative out, that comes out as an I for imaginary number. So this came out as an I. We're left with radical 9. The square root of 9 is what? 3. So in your next math class, you won't be writing that. That'll actually be marked wrong. This is the correct answer. If you remember this from eons ago when you took this, that's fine. You can go ahead and write that. If you're looking at that going, lady, I ain't never seen that before in my life, you can go ahead and write this. But do remember, do keep in mind that in your next math class, which for some of you, if you take it in the summer, is in a couple weeks, this will be marked wrong. This is not a real number. This is an imaginary number. So, but I will take either one of them. So I tried to be tricky because that was negative. Okay. All right, let's look at another one. See how all these wonderful things from chapters past come back? Aren't you excited? You're happy? I know you're not. All right, we only got a couple more and then we're done. This is a short section, thankfully. Okay, so the instructions are still solve. They're still solve. So this is squared. We got this little expression being squared, and then we have this. Oh, this is a perfect square. So you should go ahead and you should start off doing what? Taking the square root of both sides. Very nice. So when we take the square root of x minus 3 squared, we get x minus 3 equals, the square root of 16 is 4. So now what are we going to do? Well, we got to go ahead and we're solving for x, so we're going to move 3. How do we do that? We do it by adding 3 to both sides. That goes away. X equals 7. Now, remember I told you that when you have an exponent of 2, that means you're going to have 2 solutions, correct? Yes, correct. So now you have to go back and you have to figure out what your 2 solutions are going to be. So how do you do that? Well, what we can do is we're going to go ahead and we're going to solve. Instead of taking it all this way and then taking this number and sticking it back in up here, I'm going to tell you I want you to stop right here. So this is how far we used to go. But now that we're talking about we have to have 2 solutions, I'm going to tell you I want you to stop on this line right here. Okay? This is why. I'm about to tell you why. I want you to set both sides equal to 0. So x minus 3 equals 0. That's easy enough for you. You know that x is going to equal what? It's going to equal 3. Over here, you're going to take, and how would we make 4 0? Well, 4 minus 4, right? So negative 4 would set this side to 0. So when you look at plus and minus, when you're thinking about a plus and a minus answer, if we combine, when this is negative, with this positive, 3 minus 4 will give us negative 1, right? 3 minus 4 gives us -1. Versus up here, if we went ahead and we moved the 3 over like we just did, what did we get? We got x equaled 7. So -1 and 7 are going to be our two negative answers. This one, you're going to have to go back and you're going to have to think about it. This first answer, the 7, came from just, I'm going to say, regular solving for x, like we've done forever and ever and ever, where we got x on one side by itself, we moved 3 over. Came from just regular solving of x. Where this -1 came from taking the opposite. The opposite of -3 is 3. The opposite of 4 is -4. And then combining them, -3 minus 4 is -1. So this came from taking the opposite of, I'm just going to put the -3 and the 4 for this particular problem. So it's a quadratic. We have to have two answers. We get one answer by just solving it regular, like we always do. So you're going to have no trouble getting 7. I know you're not. The -1 is going to be a little bit trickier for you. When you get up here and you get down to solving it right here, when you're at the last step before you put everything and you end up with x equals something, this is a step right here. When you're ready to move this over and have x equals 7, this is where you look for the opposite of whatever that is and the opposite of whatever that is. And then you put them together. You find the sum. And that's going to be your other solution. You're going to have to go back and you're going to have to look at this. And please be sure you work your homework problems that have these types of answers. We're going to do some more of these. Okay. Let's do another one. This takes practice. So the beginning equations that you work out in this section are very short, very quick to solve, but then you get back to some of these later equations and they take a little bit more. Okay, so this is very similar to the other ones. So what are we going to do? We're going to take the square root of both sides. So if we take the square root, I'll show you another way to write this. Maybe it'll be easier for you. So what did I do on this? I went ahead and I took the square off of that side, but I went ahead and instead of taking the square root of 36 first, I did a plus and a minus. So what am I going to do now? I'm going to go ahead. Like I said, we're doing the same thing we just did. I'm just showing you a different way to write it. So now you can look at this as two different ways. You can look at this as x plus 2 equals positive 6. And x plus 2 equals -6. I don't know if writing it this way will be easier for you than the way I just wrote it. So let's go ahead and solve for x. So we got x plus 2. We're going to subtract 2 from both sides. That's going to give us 6 minus 2 is 4. Over here, we're going to subtract 2 from both sides. That's going to give us x equals -8. So maybe that's an easier way for you to think about it. It's a little bit more organized way for you to write it out. So either way you want to write it, I don't care. This is just a little bit more organized. I know some of you guys need, you know, a lot of structure. So if the previous example you were a little bit confused on, maybe this is going to, you know, resonate with you better. When you get up here, you take the square root of both sides. Go ahead and take the square root of the left. Then go ahead and add your plus and minus before you find the square root of 36, and then work it out both ways. Instead of working it out one way and then taking the opposite of all the numbers. You know, maybe that confused you. But you can work it out either way. I don't care which way you go. So hopefully if the other way didn't make sense, this way was a little bit easier for you. Let's try again and go whichever way you want to on this next one. I'm just happy that everybody can get the correct answer. Because this is pretty much where the next math class picks up, is here. You go in and they say, oh good, you had 0031, you know how to do this, let's get started, and they pick right up. Okay. So right away when you look at this, you go, okay, I can take the square root of both sides. All right, let me go ahead and write it down. I know some of you are already seeing it, and yeah, you could stop. But if you don't see it, you should see it by now. If I take the square root of this side, oh, hang on. In this class, can I take the square root of a negative number? No. So what do? Don't try to show off and show me what you know. Look at this and go, oh. There you go. I don't want anybody getting it wrong because they're trying to take eyes out to show me that they know a whole bunch of stuff they don't need to know yet. Please just look at this and go negative number under the radical. This is my answer and write it down. Just please. Because on the next test, these problems are going to be, I don't know, 6 or 7 points apiece. It's going to be a shorter test than the other one, which means that they're going to be worth more points. So if you were right up here at the very beginning when you saw this problem and you said, hang on a second, I'm going to have to take the square root of both sides and this is negative, you could have looked at it and you could have written this down way up here without actually writing anything out, and that would have been fine. I would have taken that because I know some of you, especially after you study, you're going to see that. Okay, I have one more problem for you, and of course, as always, it's the most complicated. Don't blow it off, because I promise you're going to have one of these on your test, not because I like to torture you, but again, because this is where your next math class is they're going to pick right up. I know the teachers that teach next math class, and they're not going to go, oh, we got to do review. They review this entire class in maybe 2 weeks. So what you've just spent 16 weeks on, they're going to spend about 2 weeks on. Okay, so we look at this, and all of this work is on that last page. So we look at this and we go, okay, we're going to go ahead and we're going to take the square root of both sides. I'm going to write smaller so I can get all this on here. And you look at this and you go, okay, this is going to give me 2x minus 5 equals 18 is not a perfect square. No, you're right, but guess what? You can break it up into the square root of 9 and the square root of 2. Why would I do that? Because 9 is a perfect square. The square root of 9 is 3. The square root of 2 is just the square root of 2. I just write it down. So I've simplified that side as much as I could. Because remember, we did this in the other section, and we said we break these up where we can. Okay, so now that I have that, I'm looking at this, right? And I go, okay, I'm still solving for x. This is a lot of stuff. I don't know what to do. One thing at a time. Here's your x. You got your 2 and your 5. Who goes first? You know 5, the constant, moves first. How does it move? I got to add it to both sides. So that's going to cancel. So you're going to have 3 radical 2 plus 5. Now, when you look at that, you got to ask yourself, am I going to do anything with that 5? No, I'm not going to add that 5 to that 3 because this 3 is being multiplied by that radical. So I can't just go 5 and 3 is 8. That's not correct. This is 3 radical 2 plus 5. Now remember, I'm solving for my x. It still has a 2. How do I get rid of the 2? I have to divide by 2. Simple enough right there. What about that? Who gets divided by 2? Everybody get divided by 2. So that's going to cancel over there, leaving me with x equals 3 square root 2 plus 5 over 2. Hopefully you're going, well, hang on a second. Aren't there supposed to be 2 solutions because it's squared? Didn't you say something about a plus and a minus? Yep, I sure did. Where's my plus and minus go? It doesn't go here in front of the radical. It doesn't go there in front of the radical because you have the 3 being multiplied by that. What's actually in this going to become plus and minus is going to be back here. It's going to be plus 5 and minus 5. And that's something that you're going to have to work on, you're going to have to think about it, and you're going to have to get okay with it. So both of those are my answers. I have to remember, I have to have two answers because it's squared. And my two answers, I'm always going to have a positive answer. I'm always a positive answer and a negative answer. And typically, like on the other problems we did, it's just going to be something that's going to show up in your solution set. When you find the square root, you can just put the plus and the minus in front of that 6. That 6 came from 36, which was a perfect square. That's why you could just hook it onto that 6. Where down here, you don't have a perfect square. You got the perfect square of 9, but you still got radical 2 hanging out. That's why we took and we made the constant, the whole number, the constant, the plus and the minus. And I know some of you, I'm not going to say who, but one of you told me, I didn't understand how to work a problem, so I just memorized the steps of how to do it. Girl, I hear you, because I did the same thing in math too. Sometimes you just got to memorize the steps so you can work it and learn how to do it later when you get more information. So, you know who I'm talking to. If you memorize the steps on this one, it'll make it fine for the test. You'll be able to do it on the test. You'll be able to take it into your next math class, and you'll be right where you need to be to just pick up so you won't be behind. So, do what you told me to, or do what you told me you did on that one test. When you didn't know how to work the word problem, you just memorized it. That'll work for you here. Okay. All right, guys. So this is 17.1. 17.2 and 17.3 are longer, and they are tiring. So I'll get those videos up in the next couple of days. You're probably going to maybe want to watch them. Maybe take two, watch half of it and then come back and watch the other half, because it's going to be long and boring. So, all right, guys, get up to date on your homework, and I will talk to you soon.